This is Kelly Hill, Executive Editor of RCR Wireless News. I am happy today to be talking to Mike Thelander and Emil Olbrich from Signals Research Group. How are you guys doing today?
We're doing good, thank you.
Great.
Thanks for having us.
Absolutely, happy to have you. So we are going to be talking about one of your more recent reports, Apples to Apples, and talking a little bit about sort of the methodology behind it and you know why this testing is relevant. And getting into some of the broader trends that came out of that report. So let's talk a little bit. Let's start off a little bit with you know, how was this testing approach different from what Signals usually does?
Yeah, so typically we're very radio access focused. So going out and looking at how well does the radio perform, doing full buffer data traffic, really trying to maximize the radio channel to see things like spectral efficiency, those types of things. How well does 4x4 MIMO work, for example? This test is completely different in that it really focuses at the user experience. Mm-hmm. And the argument is basically, and we proved this in the study, is that data speeds at the end of the day don't really matter for most user applications. Just as, you know, 5G NR or LTE doesn't necessarily matter. What matters is how well does your YouTube video play? How fast does your web page load? Those types of things. And that is not necessarily a direct reflection on the data speed. So we still have our data speed hat on. We'll continue to do RF performance analysis. But in this case, it's really looking at what do the consumers care about.
Okay.
And I would just add that this is really a, in addition to user experience, it was a network level test, where, you know, we're looking at 3 different networks at a network level, as opposed to we might be just in one cell site or something like testing a particular feature. So it was pretty comprehensive from that standpoint too.
Okay, great. Because I thought that was one of the interesting things that came out of your conclusions was that the fastest network is not necessarily the best network. You know, so can you talk a little bit about what you folks tested and sort of what went into, because you actually did end up ranking a network best, but it wasn't straight up speed. So let's talk a little bit about, you know, what factors went into that and why those particular factors.
Yeah, so first of all, when you talk about peak data speeds, kind of the popular way to do it is to push lots of data traffic to the mobile device. You may be doing that from a server that sits in the operator's data center. And so you're basically taking away a large part of the operator's network. On top of that, most user applications don't necessarily generate gigabit type data speeds. So instead of doing that, we looked at applications. So for example, social media. We looked at web page load times. And to the extent we looked at interactivity testing as well. We also looked at, I mentioned YouTube. We also have, you know, looking at basic HTTP browser type performance or sending small amounts of data to the smartphone. So it's not about how fast can I download a gigabyte file. It's much more so about the smaller data transactions. So to the extent we actually measured data speeds, and we did, it was not over periods of tens of seconds and hundreds of megabytes of file data transfers. It was actually a very small data package, which is more conducive or more appropriate for what most consumers do in their networks.
And that and the specific tests you included, though, I believe in another conversation we talked about how they were based on ETSI's TR 103559. Can you talk a little bit about how that relates and why you folks chose that particular approach?
Emil, I'll turn that one over to you.
You know, and I'll take a quick stab, Mike, you can add in. I think the biggest thing is that it really provides a framework that's open and well-defined, right? So this has been defined by the European standards. And so in Europe, a lot of the networks are utilizing this. There's companies that have utilized this. And the big difference is now you can see all these different parameters and KPIs that we've talked about in our reports in the past, how they're used, what the weighting is for each one of those. So we're taking lots and lots of different parameters that go into that network score that you were talking about, that, you know, the quote winner. Well, all those get kind of boiled together and culminated with different weights to them and different scores with regards to, you know, RF performance, latency of packets, throughput, the quality of the video. And so being able, we could have measured those using a lot of different proprietary tools, but being able, I think the real benefit of this is that it was all in one tool set. It allows us to, we can burrow down if we want into those lower level layers. But now having this kind of framework, we understand even as testing it and writing about it, how an eventual score gets evaluated. And so being able to go back and now you can take a look, and one of the reasons for apples to apples is that we can take disparate networks and compare them and say, oh, how are their scores in this particular realm, and what do they look like from year to year, and kind of trend that. So I think it's an effective way to do that, as opposed to other proprietary methods which do similar things, but it's really unknown what's going on.
And I think just to add to that, since this is an ETSI TR, I mean, it's developed in part by mobile operators. So mobile operators are weighing in and saying, these are the tests that we think are important. These are the KPIs. These are the thresholds that we think are required to deliver a good user experience. And you can download that TR. Anybody that has access to the internet can download the TR, understand exactly the tests that are done, the number of tests, how the scores are determined, how you weight the scores, et cetera.
That's really interesting, because then I think that when you standardize test methodologies like that, you really get a chance to, as you guys called it, compare apples to apples over time, over networks, over different technologies, and it gives you presumably a more consistent view of, network improvements, ideally, but it sounds like the view over time is probably very valuable.
That's correct, definitely.
Okay, great. So let's talk a little bit about something that hasn't been standardized yet, and that's interactivity testing. But you guys did do that as part of this. So talk a little bit about what interactivity testing is, and sort of what what's in motion there.
Yeah, so interactivity testing, I mean, at a very high level, it's basically latency testing. But if you think about a typical latency test, you're basically sending a packet back and forth between, say, a server and the operator's data center, and it may be one packet or a couple of packets. And that measures latency, but it doesn't measure interactivity. So we looked at two different profiles. One was called constant long, and one was called e-gaming. But basically what we're doing here is sending very small packets, and the packets may vary in size one to the other. We're varying the frequency of how often those packets are being sent. And the packet sizes themselves are actually much bigger. They're small, but they're bigger than what you would normally send with a typical latency test. So this is more reflective of what somebody might be doing if they're gaming and they're on their control panel and they're hitting the button back and forth. It's lots of interactivity. It's unpredictable in fashion. The packets are going out to a server in the network. And so this is a much more challenging environment than just a simple latency test, because you're testing all facets of the network. The data speeds may only be 3G, like even 2G, but what really matters is kind of the response time of the network, making sure that you send a packet, you get the acknowledgement back in a relatively short period of time. And what we found in these results, I mean, again, the operators have not deployed any QoS or any network slicing in their networks. But if you look at the performance of networks today, be it LTE or 5G NR, it's very clear that they're not capable of really supporting good interactivity based upon these tests. And I should add, these tests are not currently part of the ETSI TR. It's something that's a work in progress. And I would definitely imagine at some point in the not too distant future, we see some form of interactivity test being introduced into the TR.
Emil, thoughts?
I'll just say that, the interactivity, this is a real common thing. You think about using direct messaging on Twitter, or using Instagram or Snapchat or something like that. You have a lot of small packets going back and forth. And then you take that to the next step with gaming. And whether it's a high resolution game or just, some fun game that you're playing that's a web-based application, that interactivity becomes a big deal. And I think it exposes some of the issues. Mike talked a little bit about this. It's a network test in so much as Some of the applications that are used, the servers sit within the carrier's network. So you're really testing the radio access network. In our aspect, we're testing end to end. So it's going all the way through the carrier's network out to the internet. So all of the different CDN routing and all the different things that come into play in latency, we get to see the effects of that. So you could have a really well optimized radio network, and it could be running on NR, but you could have issues in your core network and how things are routed and the location of that content. So this helps, bring that to bear. And so I think as you see more, applications, that are, going back and forth between individuals or groups of individuals, this type of testing is going to get pretty important.
So, okay, another question then. So when mobile edge computing, Mac, when we see that more widely deployed, will that show up in this type of testing, ideally?
It will if you're testing to MEC. So I mean, operators today are deploying MEC functionality. It's a question of what functionality, what applications, et cetera, they actually push to the edge. And I think they're going to be very selective to start and what they push, and then over time build that out. So yes, I guess it depends.
Okay. So then, but presumably maybe someday, a gaming company might be able to say, okay, we want to do interactivity testing on this, because this is going to help us decide whether or not we want to deploy on, Verizon and AWS's edge servers in, for 5G in this particular city. So
exactly.
Okay, great. All right. So anything else that was anything surprising to you about the results, or just about how this testing came out?
Well, you kind of alluded to it, that the operator with the slowest data speeds actually came out on top. And I guess I was expecting something along those lines, but it definitely proved itself out. And just to be blunt about it, AT&T had quote unquote the slowest network. That's the slowest network based upon sending very small amounts of data. But when you look at overall performance, I mean, they really dominated over Verizon, followed by T-Mobile. And it really came down to lots of things in their network that went well above and beyond just data speeds. The other thing to point out too is that really the purpose of this study, I mean, we're saying AT&T had the best network in the Dallas area. That wasn't the real focus of the study. I mean, ideally, there were things we could have done in the testing process to really fully implement the TR, the ETSI TR. We didn't necessarily do that. What we wanted to do is say, okay, let's take the TR and let's compare 3 networks and look at what really matters. So when you do that, obviously an operator comes out on top, second and third place, but ultimately we're not claiming that was the mission of the study. It was really to identify performance differences. And when you do that, ultimately somebody wins and somebody doesn't.
Okay. Emil, any closing thoughts on the results?
No, I think we're excited to, follow on this, on the interactivity testing, looking at, gaming on the network. I think in the report, you see that, for HD content, AT&T was the only one to do that. And it's easy to look at that 90th percentile and look, under the best conditions. But what does it do at the 10th percentile? And that's where we really see that differentiation, right? And I think that was the more interesting aspect, is that under ideal conditions, I mean, they're using the same infrastructure vendors, very similar architectures, but those nuances really become bigger in the poorer performance, and that's where we like to look at and kind of differentiate between vendors, the mobile network operator. So anyway, we're excited to kind of follow on and do some additional testing along these lines.
Okay, sounds good. I'll be keeping an eye out for it. Thanks so much to both of you for joining us today.
Thank you.
Thanks.